Have you ever wondered how large-scale applications handle millions of messages without everything slowing down or breaking? That's where message brokers like Apache Kafka and Kafka come into the picture. At first glance, Kafka and RabbitMQ may seem like they do the same thing. Both allow applications to communicate asynchronously, both can handle large volumes of messages, and both are widely used in modern distributed systems, but they are designed with different ideas in mind. Let's start with Rabbit Visual Message Broker. Imagine you have an application that produces a message such as ask this payment. Instead of sending that request directly to another service, the application sends it to Rabbit. Rabbit Aviation stores the message in a queue and a consumer service picks it up and processes it. This approach is excellent when you need reliable task distribution. For example, imagine an e-commerce application. When a customer places an order, your application might need to send emails, update inventory, process payments, and generate invoices. Rabbit can distribute these tasks to different services and make sure messages are unwaiting invoices. Rabbit invoices and make sure messages delivered reliably. Rabbit Finwelly also provides powerful routing features using exchanges, queues, bindings, acknowledgements, and different messaging patterns. Now let's talk about Kafka. Apache Kafka is better distributed as a distributed event streaming platform. Instead of thinking primarily in terms of a queue where messages are consumed and removed, think of Kafka as a durable distributed log of events. For example, whenever a customer places an order, your application can publish an order-created event to Kafka. Multiple services can consume that event independently. The payment service can process it. The inventory service can process it. The analytics service can process it. And another service can consume the same event later. One of Kafka's biggest strengths is scalability. Kafka can handle enormous amounts of data by distributing messages across partitions and brokers. Consumers can also work together in consumer groups to process events in parallel. Another important difference is message retention. In Rabbit, messages are generally consumed from queues and acknowledged after processing. Kafka, on the other hand, can retain events for a configured period or based on storage policies. Consumers track their position in the stream using offsets. So when should you choose Rabbit? Envision Rabbit Amware's a great choice when you need traditional messaging, task queues, flexible routing, request distribution, or reliable communication between services. And when should you choose Kafka? Kafka is a strong choice when you need high throughput event streaming, real-time data pipelines, event-driven architectures, analytics, or systems where multiple consumers need access to the same stream of events. Here's a simple way to remember the difference. Rabbit is often about delivering messages and tasks to consumers. Kafka is often about storing and streaming events at scale. That doesn't mean Kafka is always better than Rabbit. They solve different problems, and the right choice depends on your architecture. In fact, some large systems use both. For example, Kafka might handle high-volume event streaming and data pipelines, while Rabbit handles background jobs and task-based communication. So, if you're building a distributed system, don't simply ask which one is better. Ask a more important question: what kind of messaging problem am I trying to solve? If you need flexible message routing and task processing, Rabbit may be the better fit. If you need scalable event streaming and high throughput data processing, Kafka may be the better choice. Understanding this difference can help you design systems that are more scalable, reliable, and easier to maintain.